All right, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video and I'll go over the correct answers. So for the factoring, you should have x minus 8 times x plus 7. For the math knowledge question, they give us an isosceles triangle here, and we want to know what are the measures of these two angles. So 70 plus 2 times the angles that we don't know, because there are two of them, is going to equal 180. So 2x will equal 110, and then if you divide by 2, x will be 55 degrees. So that would be D for your answer. We are looking at lesson 36 today. We're going to be looking at right triangle congruence theorems. So hopefully you'll understand how right triangle congruence theorems work after this lesson. So this is theorem 36.1. It's the leg angle, the LA right triangle congruence theorem. If you have a leg and an acute angle of one right triangle that are congruent to a leg and an acute angle of another right triangle, then your triangles are congruent. So we have angle and a leg and our right angle. So we want to use the LA congruence theorem to prove that the two triangles are congruent. So we can do a 2-column proof here, or we can do a paragraph proof. It's not a long proof, so I'm going to do a paragraph proof. So the diagram shows that triangle ABC is a right triangle, and triangle XYZ is a right triangle. So it shows that they are right triangles. So to use your right triangle congruence theorems, you have to mention that they are right triangles. It also shows that AB is congruent to XY, and it shows that angle C is congruent to angle Z. So it shows all three of those. So therefore, triangle ABC is congruent to triangle XYZ by the LA congruence theorem. I left off congruence theorem. Okay, so that's all you really have to do on these. You tell that they're a right triangle, and then you show that you have a leg and an angle pair that are congruent, so your triangles have to be congruent. Okay, looking at the next theorem, 36.2, it's the hypotenuse angle, the HA right triangle congruence theorem. So if you have a hypotenuse and an acute angle of one triangle are congruent to the hypotenuse and acute angle of another triangle, then the two triangles are going to have to be congruent. So we want to use the hypotenuse angle congruence theorem to prove that the two triangles are congruent. So we can do a 2-column proof on this one just to show you that you can still do them, or you can do a paragraph proof if you'd rather, or you can do a flowchart proof, whichever is fine. So the first thing would be our given information, which would be that triangle DEF and triangle QRS are right triangles. And that would be from the given. We are also given that DF is congruent to QS. So both of those are your given. We also know another thing that we know in the given is that angle F is congruent to angle S. So all three of those would be our given. So then you could break that into three separate statements and reasons, but all three of them would be the given. So it's fine to put them all here. So then from that, triangle DEF is congruent to triangle QRS, and the reasoning would be the hypotenuse angle congruence theorem. So, whoops, that should be step 2. So it's not a long proof on these typically, because they're going to give you most of the information that you need. Okay, so now we want to sketch this one here. We have PQR with a right angle at Q, and we have XYZ. And it wants us to write a paragraph proof to prove the hypotenuse angle triangle congruence theorem. So on this one, you're not going to be using the HA triangle congruence theorem. You're going to have to prove that theorem. So we have two triangles here, and we want to prove that they are congruent and prove that the HA triangle congruence theorem works. So by your right triangle, no, by the right angle congruence theorem, angle Q is congruent to angle Y, because they're both right angles. That's what the right angle congruence theorem says. And then if this side here is congruent to this side, so if XZ is congruent to side PR, and if one of our angle sets, so we'll say P is congruent to X. So if the sides are congruent and if those angle pairs are congruent, then the two triangles are congruent. And it would be by angle, angle, side. Because we would have angle, angle, side, angle, angle, side. So that's another way to prove that the triangles are congruent. It just requires a little bit more words, I think, than to prove it by the HA, right triangle congruence theorem. Okay, there's another theorem, 36.3, the leg-leg right triangle congruence theorem. If the two legs of one right triangle are congruent to the two legs of another right triangle, then the triangles are congruent. So we want to use the LL congruence theorem to prove these are congruent. So it is given that triangle XYZ and triangle MNP are right triangles. That side MP is congruent to side XZ, and side XY is congruent to side MN. Therefore, the triangles are congruent by the leg congruence theorem. So that would be all you would need to put there. Okay. Looking at the next one, this is the hypotenuse leg right triangle congruence theorem. If you have a hypotenuse and a leg that are congruent to a hypotenuse and leg of another triangle, then the two triangles are congruent. So those are the four that we're going to be using. I'm going to go back to the first one real quick. This one would be angle, angle, side. We could use instead of the LA congruence theorem if you wanted. This is the theorem 1. Angle, side, angle would work here. You could do angle, angle, side here. We could have done angle, angle, side here. We did angle, angle, side on this one. On this one, we could have done side, angle, side. Side, angle, side on this one could have been used. Or on this one, this is the only one that you can't use another one, because this would be A, S, and S, which, remember I told you, we're not ever going to be having that combination of the letters, or SSA. That's not going to work. So the hypotenuse leg right triangle congruence theorem is the only one that you have to use this specific one. The other ones, if you used angle side angle or angle side or side angle side, it would still work. But this is the only one you have to absolutely use this one. Okay, so the hypotenuse leg one is the one you absolutely have to make sure that you use sometimes on your right triangles. So we want to use the HL congruence theorem to prove the triangles are congruent. So let's do a two-column proof on this one, just for practice on those. It's not going to be terribly long. So we know that triangle RPS and triangle JHK are right triangles. We also know that side RS is congruent to side JK, and side RP is congruent to side JH. And the reason there is the given. And then next one, the two triangles are congruent. And the reasoning is the hypotenuse leg congruence theorem. Okay? So that would be for part A. Those are not long proofs. You just basically have to tell the information that you're given, and then usually that's all you need to be able to prove that the triangles are congruent. Now we're going to look at the hypotenuse leg triangle congruence theorem. So we want to prove this theorem on these two triangles. So we know that they are congruent by the hypotenuse leg triangle congruence theorem, and we want to prove that theorem actually works. So we're not going to use the hypotenuse leg triangle congruence theorem anywhere on here. So we'll do a two-column proof. So the first thing that we want to say is that our triangles are right triangles. And that's given because it shows that they are right triangles. We also know that A equals X and C equals Z. And that's given. So you could have put that in one step if you wanted. We also know, since they are right triangles, a squared plus b squared has to equal c squared, and x squared plus y squared has to equal z squared. And that's from the Pythagorean theorem. From there, we know that A and C are equal, so we're going to solve for B and Y here and see what they equal, because they're the only ones that don't have anything marked. So B would equal the square root of C squared minus A squared, and then Y would equal the square root of Z squared minus X squared. And that's for solving. You're just solving for B and Y. And so then we can substitute. We know that A equals X and C equals Z. So in place of A and C here, we can say that B equals the square root of Z squared minus X squared. And that's from substitution. And then, if you notice, B and Y are both equal to the square root of Z squared minus X squared. So that means that B has to equal Y. And so that's also from substitution. And so then, these triangles are congruent. They didn't tell us what to name them. So the triangles are congruent, and that's by the side, side, side congruence postulate. Because we just proved that these are congruent. So that would be how you can prove that triangles that are congruent by the hypotenuse leg are congruent by side, side, side as well. Okay? But that would be a lot more proof to have to go through than just using the hypotenuse leg triangle congruence theorem. Okay, so let's look at this next example. So Jerome is using stained glass right triangles to make a window, and he has two right triangles, and he knows the hypotenuses are the same length. What other measures can he use to prove the triangles are congruent, and what theorem applies to each? So we could use a pair of congruent acute angles, and that would be by the hypotenuse angle theorem. Or he could use a pair of congruent legs, and that would be by the hypotenuse leg congruence theorem. So that'll be a question that you'll have on a test related to these, and they're actually going to end up being 9 different ways that you could prove your triangles congruent. It'll ask you to prove all of them, and you've got to actually tell about all of them. So they like to do this, what theorem could you use for these triangles, and then list all of them that'll apply. Okay, so let's look here. Let's see if y'all can do this proof by yourself. So pause the video, and then once you have attempted it, y'all can unpause the video and I'll go over the correct answer. So for this one, we know that triangles ABC and DEF are right triangles. We also know that legs AB and DE are congruent. And we know that the acute angles A and D are congruent. From that information, that means that the two triangles are congruent by the leg angle triangle congruence theorem. And that's all you would have to put on that one. Okay? So hopefully your proof said basically that. Looking at the next one, use a diagram to answer this one. Y'all try it by yourself and then unpause the video and I'll go over it. So for this one, they tell us that triangle ABD, no, that should be a C here. ABC and DEF are right triangles. They also tell us that the hypotenuse AC is congruent to the hypotenuse DF, and the angle A is congruent to the angle D. From there, we can use the hypotenuse angle triangle congruence theorem to prove that the two triangles are congruent. So that would be how you would prove those two triangles are congruent. looking at this next one, we want to prove that they are congruent, so y'all try that one by yourself and then we'll go over it. So we know that the two triangles are right triangles. Also, this side is congruent to this side and this side is congruent to this side. Therefore, triangle ABC is congruent to triangle DEF by the leg-leg triangle congruence theorem. So again, these are not difficult proofs. You basically just have to tell the given information, and then usually that's all you need to tell that your triangles are congruent. Okay, looking at this one. Suppose that the triangles are, or suppose that information is given, and then prove that the triangles are congruent. So y'all try that one by yourselves. So we're given that the two triangles are right triangles. We're also given that this one is congruent to this side, and then this side is congruent to this side. Therefore, we can use the hypotenuse leg congruence theorem to show that the two triangles are congruent. So that's all you really have to do. All right, so now we're going to look at our challenge question. Y'all see if y'all can try this one by yourself, and then I'll go over it. So the givens are that PA is equal to AB, which is equal to BR. It also tells you that PA, B, and R are collinear. It also tells you that PQ, is perpendicular to PR, and RS is perpendicular to PR. And then it also tells us that PQ is equal to RS. So now we're supposed to prove that ABC is an isosceles triangle. So we can prove that this triangle is congruent to this triangle by the leg-leg theorem. And then if those two triangles are congruent, that means that this angle here is congruent to this angle here by CPCTC. And so since those two angles are congruent, that means that this side and this side have to be congruent, and that proves that it's an isosceles triangle. So that would be how you could prove that one. Okay, so your homework is 1 through 30 tonight. So make sure that y'all do that so we can go over your questions tomorrow.